Podcasting from the Deep Sage 9 Observatory in the high desert near Taos, New Mexico, this is the Deep Sage 9 Starcast. Welcome back to the Starcast for the week of May 10th, 2026. I'm your host, Jay Schaefer, and with me is my co-host, Mike Lewinsky. Howdy, Mike.
Good morning, Jay.
So, Mike, what's our space weather looking like over the next couple days?
Well, Jay, just about 2 hours ago, sunspot 4436 erupted and produced an M5.7 class solar flare. It did hurl a CME into space, but we don't know yet if the Earth is in the line of fire. We're also keeping a close eye on sunspot 4432, which is growing rapidly and may produce M-class flares as well. On top of all of that, we have a hole in the sun that is streaming solar wind at the Earth. And so even if it weren't for that CME today, we're still expecting to see geomagnetic storms late this week, probably Thursday, Friday. So NOAA currently gives us a 40% chance of Class M flares and a 10% chance of Class X flares over the next 48 hours. Our geomagnetic storm forecast is putting a 20% chance of active conditions, which is the lowest level here at mid-latitudes for the next couple days. And up at high latitudes, there's a 30% chance of severe geomagnetic conditions. So we're definitely keeping an eye to the north. What's happening in the night sky this week, Jay?
Yeah, so on the sun weather, yeah, I'd seen the headline that things were quieting down, but it actually sounds like we've had a couple sunspots that are going to keep things perked up. So that's heartening. Um, so this week is the new supermoon. The actual moment of the new moon will fall on 2001 UTC on May 16th, 2026. And that is about 2:01 p.m. Mountain Daylight Time here. And in fact, this is the second of 5 new supermoons in a row. So we're going to get a bunch of supermoons over the next couple months. And so this one will be 222,819 miles away. And for those of you that use a sensical measuring system, that's 358,594 kilometers away. Now compare that with the average moon distance of 238,900 miles, or 384,472 kilometers. That is a little bit closer. And so new moons rise and set with the sun, as we probably all know. And nights around the new moon are perfect for stargazing. And so the nights between the waning crescent moon and the last quarter moon of the last quarter, after the last quarter moon, and the waxing crescent moon before the first quarter moon are sometimes called the golden nights, or the best nights for astronomy. And so we'll discuss that a little bit later in the Starcast. And then on the planetary front, we've still got Jupiter in the evening sky after dusk. And if you're an early riser, you can catch Mars and Saturn just before dawn this week. So, Mike, what have you got for us in space news?
Yeah, Jay. First up, the James Webb Space Telescope has directly studied the surface of an exoplanet for the first time. This planet is designated LHS 3844b. And when I start reading a story like this, I'm always, curious, well, how do they get that designation? So I, took a pause and went and dove into how LHS 3844b was named. So the first part, the letters, are the star catalog where the object is found. In this case, the host star is LHS 3844. And in particular, LHS stands for the Luyten half-second catalog. It's a catalog of about 4,000 stars with a proper motion greater than a half second per year, hence the Luyten half-second catalog. And that was last published in 1979 by Willem Jacob Luyten, based on the Palomar Observatory Sky Survey and other plates. And now, so we've got LHS is the catalog. 3844 is the order in which the host star was cataloged. So out of the 4,000 stars, this one was pretty much near the end. And then the letter B. Now, this part of the designation, I think, is the trickiest. So the exoplanets get designations of letters starting with B. They say that the star is going to be A in this case.
Oh.
However, it's a lowercase b. The star would be the uppercase A. And if it's a binary system, then there could be an LHS 3844. Lowercase b would be the first planet that is discovered, and uppercase B would be the binary twin. I think that that's incredibly confusing, and I really wish that they would fix that. Um, but yeah, so if they discover a third exoplanet, it's going to be C. A fourth exoplanet discovered is D. You might think, oh, well, they should do it, based on its position from, in the orbit. But then they run into the problem of we discovered a new inner planet, and now we have to rename the other ones. So it does make sense to me that the B, C, D is in order of discovery and not in orbital position. So back to this study, the James Webb Space Telescope used the Mid-Infrared Instrument, which is acronym MIRI, and we had astronomers at the Max Planck Institute for Astronomy who made these measurements. Now, this was challenging because this exoplanet is about approximately 30% larger than the Earth. It's about 48 and a half light years from Earth, but it is in very close proximity to its host star. It is tidally locked, and it is completing its orbit every 11 hours. So a year on LHS 3844b is 11 hours long. And being tidally locked, it means one side is permanently facing the star and one side is facing deep space. So separating the light from the host star to characterize individual surface features was challenging and only possible thanks to the amazing sensitivity of the Webb's instruments. They've discovered that this is the dark side of the planet was constantly bombarded with radiation, and they found the average surface temperature is approximately 725 degrees Celsius or 1,340 degrees Fahrenheit. And they were able to determine that this is a fairly rocky planet. They're comparing it to Mercury as maybe the nearest analog that we have in our solar system. So this was hot, barren rock devoid of any atmosphere. Most of the exoplanets we've discovered and studied, we're looking at atmosphere and not surface. So we don't yet have any libraries of exoplanet geology. This is a first. This is the start of studying the surface of planets outside of our solar system. So this is really an exciting step forward in our study of exoplanets, and I'm looking forward to number 2 here.
So on that, so it was the direct observation just during the transit of that star, of its sun, or how was that actually imaged? Do you know?
Well, it is using the mid-infrared range, so they're not using uh, actual visible light, but the infrared. And they've come up with a chart to show and we'll include links in our show notes, that the spectrum, infrared spectrum of the hot day side contrasted with the host star show that we've got some magnesium and iron-rich mantle rock, as well as some basalt and silica crust that are visible in the spectra. So yeah, they did have to do some high-end math to derive the brightness contrast with the host star and the planet's surface. This was not an easy feat for them. Um,
Yeah, and of course, this goes to our spectrometry. Spectrometry is, I think I'm pronouncing that correctly, is that that's how we determine what elements are present when we image these things, whether it be stars or planets. Is that correct, Mike?
yeah, spectroscopy. Yeah, that's
Spectroscopy.
very useful for both planets and stars in helping us, analyze composition. Of course, spectroscopy gets used in other physical sciences on Earth, but it's definitely a big part of our astronomical processes. So, exoplanets might have life. This one probably doesn't, but others might. And so, I think our other big story this week is the release of the Pentagon UFO files tranche number one. The Pentagon just pulled back the curtain on a large cache of unidentified anomalous phenomena, or UAP files, through a new public portal called Pursue. This first rollout includes 162 records, ranging from declassified FBI interviews to fascinating transcripts from the early days of space exploration. Among the highlights are archival materials from the Gemini and Apollo missions, including a 1965 report from astronaut Frank Borman about a bogey accompanied by hundreds of small particles, and a 1972 photo from Apollo 17 showing a curious triangular formation of lights. Many of these sightings have been discussed in hushed tones by enthusiasts for decades. Now, seeing the original NASA transcripts and government memos in one place adds a whole new layer of legitimacy to that conversation. Some of the modern reports even include military pilot encounters as recent as 2024. So the Pentagon maintains there is still no definitive evidence of extraterrestrial technology. The sheer volume of data being released, with more promised on a rolling basis, does suggest there's a major shift towards transparency. It's a vivid reminder that even as we peer deeper into the cosmos, some of the most compelling mysteries might be happening right in our own backyard. We'll also include a link in the show notes to a video where Seth Shastak, a senior astronomer at the SETI Institute, shares his insight on the newly released Pentagon UAP files and their implications for the search of extraterrestrial life. So what do you think, Jay? This is,
Well,
kind of exciting.
yeah, and being pretty skeptical and in the tradition of the where are they uh, camp, I would say that again we're saying yeah these are unknown phenomena, and an unknown phenomena doesn't necessarily means that it's an extraterrestrial or extraterrestrial life or extraterrestrial technology. And it's kind of like, I heard one of your neighbors talk about orbs from another dimension, and and they were convinced that these were orbs from another dimension, visitors from another dimension. And so science would say that we can't prove that they are not orbs from another dimension, but that is not to say that they are orbs from another dimension. And so that's the same thing that we can say that we can't prove that they are not a technology from extraterrestrial life, but that is not to say that they are technology from extraterrestrial life.
Yeah, I'm right there with you, Jay. And as far as my own personal skepticism, um, And, I think we both have our kind of unique perspective of having, thousands of hours of night sky time lapse video. It's not just that we're out there, photographing, taking a few pictures every night, capturing, a few minutes of the night sky. I just finished compiling, sunset to sunrise today, and there was nothing in my captures that made me say, "Oh, wow, that might be alien craft." Could
Hmm.
it be that something that appears like a satellite that's in orbit is of extraterrestrial origin? Sure, but it's indistinguishable from the thousands of man-made satellites that are up there from my vantage. If I saw one of those satellites suddenly do a 90-degree turn, I would get pretty excited. I would be calling that out and publishing
Yeah.
it.
Well,
And
and it would be defying the laws of physics
right, right,
as we know it.
as we know it. And I've been doing this since 2011, so I've got 15 years of night sky photograph in the supposed hotbed of UFO activity. And not all of them in this particular San Luis Valley, but certainly I have the better part of the last 10 years between Tres Piedras and Crestone, with a short break during COVID. And it's very fun, but the more days go by that I don't see anything in an area that is reputed to be a UFO sighting hotbed, the more skeptical I become. And I want to be wrong. I want to believe, but it's getting harder and harder every day.
Well, and it goes to the Asimov statement is not, the not only is the universe as strange as we can imagine, it's stranger than we can possibly imagine. And that's not to say that there's not these phenomena out there. I'm absolutely convinced that there are phenomena that we don't understand and can't explain with traditional methods right now.
Oh,
But that
absolutely.
that's kind of being the speculative part of science.
Right.
And so, yeah, and so I just kind of wrap that up real quick, and so I think this is very interesting, but I thought this week we would discuss something a little less speculative, and so I was thinking about this week coming up, and this week is what I call the season opener. And so that's when it's starting to get warm enough at night where it's not grueling to go out there at night and do observations in astronomy. And we're in that kind of new moon period, what we call the golden nights. And so um, so, for example, is if we talk about the Golden Knights as one of the things that we do in our astronomy club is that we have as many star parties as we possibly can during these golden nights. And so we actually do our star party schedule around the best nights for viewing, which is that what we call the golden nights. And so here in May, last night was our first Good Saturday, and then next week is still going to be good on 5/16, and then if we look at the fourth Saturday, the May 23rd, then we're getting kind of toward a bright moon, and the same thing in for May 30th that we're going to be kind of in the moonlight, and then we kick off June, and so on the 6th of June, we would be kind of in that golden period, and same thing with the 13th of June. And then, of course, the next two weekends would be probably not the best for viewing because of the moon. And then we get the first two weekends in July as well. And again, the last two weekends would be less than optimal. And then August is going to be actually pretty good. Is we're going to end up with the from the 1st of August, the 8th of August, the 15th of August, and the 29th of August are all going to be kind of in that window. So that's going to be a great time for viewing. And then I'll just kind of wrap it up in September and October, which I kind of call the end of the season. So it'd be the first 2 weeks in September are going to be good for viewing, and then October, we get the first 2 weekends, and then we skip 2 weekends, and then on Halloween, we would kind of call it a good night as well. And so that's just talking about moon phases and observation to kind of avoid the moon. And uh, those are always good times to get out there. And of course, when we're talking about the um, waning moon, so the period between the last quarter moon and the new moon, the waning crescent period, to me, that's always the optimum period because that means that there's no moon early in the evening, so that basically the moon doesn't rise till well after midnight, and I'm the kind of observer that likes to get out in the early evening and do my observations. So that's for me is the perfect time.
You know,
So
Jay, I'm
Mike,
going to disagree with you there on that. I think that the early waxing moon, which is setting in the early evening, is my favorite time. We had a star party last year and hit it just right. We had a really nice view looking out over the valley at the setting crescent moon, and it was especially sweet because Venus was up there, and Venus was also a crescent, and they were both, in roughly the same amount of phase, and the crescents were oriented in the same direction. So we could look at the crescent moon in the telescope and then switch over to the crescent Venus, and it was like just a little moon, in terms of the appearance. So that was, it wasn't, the moon wasn't far enough along in that phase to really impede much observing. So for my
yeah,
money, if you can time it right, the first, I would say, 4 days after the new moon are almost the sweet spot. The moon is such an easy target for people, and even in a smaller scope, it looks really great. And it's a nice way to start a star party out.
yes, and also that that crescent moon, that the waxing crescent moon is when we get the best opportunity for Earth shine on the moon's darker side. And so, yeah, that's another thing that's nice about observing that moon during that period that you're just talking about is that often you get enough Earth shine on there that you can make out details on the shadow side of the moon as well.
Yeah. Yeah, I really love it. I'm going to rant for just a second too, Jay. I really hate daylight savings time. It just messes with my moon calculations. During standard time, as you mentioned earlier in our show, the new moon rises at sunrise. The full moon rises at sunset, and that's pretty easy to remember. New moon coming up with the sun. We can't see it because it's not in their shadow, or it's rather not the side that's facing us is not illuminated at all by the sun. Now at the first quarter moon, we expect to see setting at midnight. And the last quarter moon, we expect to see rising at midnight.
Hmm.
And that's true during daylight savings time. But once we're in, sorry,
It's
standard
standard
time.
time. Yeah.
Once we're in daylight savings time now, it's off. And
By an
I
hour.
just,
Yeah.
I just, that's all. That's my soapbox. It's a minor thing.
Well,
There's a lot of other
yeah,
reasons.
So I'm a standard time fan as well because that's basically the real time in terms of if we if you have a sundial
Right.
that doesn't lie and so um, and of course my wife she kind of practical people she goes, silly boys, why don't they just make it a half hour off?
Split the difference. Yeah, that's what we
And
should do.
and there's a lot of truth in that, it is an invention, that, our 12-hour day, our 24-hour day is somewhat of an invention.
Yes. So, Jay, this time of year, we're kind of in a sweet spot right now. As you mentioned, it's now warm enough at night that, we're not getting numb fingers and toes from standing out in the cold. And yet we're also still early enough in the season that we're not hitting the really short period of solstice. And of course, the further north you go, the more severe uh, that is the loss of nighttime. Once you're up in the main area, the sun is not really down until after 10 o'clock at night. And it's, coming up, by 4. So your night is very short. And even here, we're really only looking at, 5, 6 hours of complete darkness. And so this time and this particular next couple of weeks give us some of our best views of the core of the Milky Way of the year, really. And so, as I think about the golden nights that are coming up here, and I love that our transcript is spelling nights with a K. I feel like we're going on a quest here on the golden nights. Um, this as I think about what I'm going to be doing for the next couple of weeks, one of my goals is to get out my Sky Watcher Star Adventure tracker and put it into time lapse mode and have it pan the horizon to follow that core of the Milky Way as it rises and goes through until it disappears into dawn.
Hmm.
And we will, I'll be trying that at least the next 3 nights. We still got the waning crescent moon to contend with, but in some ways that gives the sky a little bit of a blue tint, and Milky Way core with blue tint sky is just some of my favorite wide field experience. So I'm looking forward to giving that a try. We're sort of in a lull between the meteor shower window here right now. We had the Eta Aquarids peaking last week, and I did capture a few of those. We don't really get much until I think that the Delta Aquarids at the end of July is our next big shower. So, um,
Hmm. Yeah, and then yeah, my time lapse capture last night and the night before, it was exactly 8 hours because I started. It was just dark enough at 9 p.m. and then it started to get overexposed at 5 a.m. And so I
yep,
actually did the time lapses to the minute of 8 hours.
yeah. I like this window, starting the next few nights now where I don't really need to make exposure adjustments for the moon. And I'm doing a full night time lapse, and it's, anywhere between first quarter to last quarter. I'm setting a timer to go change my exposure. Usually I'm not changing my exposure times. I'm actually dropping my ISO when the moon rises or raising it when the moon sets. And it's either, very overexposed or very underexposed if I don't do that.
Hmm.
And so that means I'm getting up at 3 o'clock in the morning and traipsing out into the field and, often really stumbling my way out there because I'm just not awake. And trying to fall back asleep after that. So I appreciate the window where I can do a full night time lapse without having to roust myself in the middle of the night.
Yeah, and so that speaks to kind of the direction to shoot as well, as often with having our cameras, I know you often put out two a night, but it's often I'm only putting out one camera a night, and then I'm kind of choosing the direction that I want to aim. And of course, anytime when the moon is beyond, the first quarter is I'm usually going north because I don't want to have the actual moon appear in my frame.
Right, exactly. For the last few days of the phase right before new, having that crescent moon rising, kind of gives it a little something extra. So, and same thing for the, waxing crescent that's setting in the evening. I often like to capture some of that in my time lapse.
Yeah, and that's not totally blowing out your exposure. And so, yeah, yeah, so we can shoot, east, west, south, or north right now. So, yeah, that's good. And so, yeah, that's in general as time, and often it's like, so the Edda Aquarius this last week or 10 days ago, I guess it was, but was um, it was to the south, and the moon was, almost, was pretty much first quarter moon, and so that was kind of washing it out along the radiant. But even facing north, I was able to get a couple fireballs, and so that was still
Nice.
good. And so, anything else you want to talk about planning your astronomy for this summer?
Boy, Jay, my my actual real big goal this summer is going to be some red sprites. I've captured these in the past, but it's always been with, my widest angle lenses and very incidental. And I did see there was a pretty active electrical storm over the Front Range last night that, the flashes appeared over the mountains. I could see that there was stuff going on over there, and I got hopeful for a minute that maybe I'd find a sprite or two. I don't think I caught any last night, but my
Hmm.
goal is to track storms from Raton to, the Panhandle of Oklahoma, and see which ones are active enough that they could be producing sprites, and then spend some time out there reviewing the wide field so that when there is a sprite producing storm in the vicinity, I can switch to a telephoto lens and try and get some nicer sprite photos. With the wide field,
Hmm.
they're very tiny, um, and you know, a few
Yeah.
degrees. And I would really like to get some. Of course, what I'd really like to do is travel out there to the Panhandle and you know get one
Hmm.
from 100 miles away where I can really
Yeah.
get capture some details, some tendrils, and more interesting stuff.
Yeah.
But
Yeah.
I
So,
don't know that my schedule is going to permit that kind of travel this summer. But I do intend to pay much closer attention to what's going on out there on the plains, and hopefully dial in on some red sprites.
yeah. And so there's the fellow photographer named Paul Smith, of course, is kind of the big gun storm chaser that captures has a lot of those sprite images that he's captured. And I guess part of his technique, and he's kind of secretive about it, and it's unless you pay him to go on one of his workshops. But my understanding is that he actually shoots video of the storms to catch the sprites and then extracts frames of that. So
That's right. That's right. I do know that he's using the Sony Alpha line, which is
very
well
sensitive.
suited for that.
Hmm. So, yeah, so we're going to wrap this up. And so we've been discussing whether or not we should continue with the Starcast. And so we haven't had a whole lot of feedback from our listeners, and we're not showing a whole lot of subscribers. And of course, I wonder if we're maybe being a little bit too um, obscure or whatever, but for whatever reason, is that we're not really getting the audience that we had hoped for. So we're kind of debating whether or not we're going to go ahead and pull the plug. And so what we've decided is that we'll do another Starcast next week, which will probably be our last. And unless we get an overwhelming response from our listeners that they want us to continue, I think we'll go ahead and kind of wrap this thing up. And just one of the things that during the duration of this Starcast is that it's just been such a enjoyable collaboration with Mike, and I've learned so much from Mike, and so much about astronomy in general, just in our general investigation and research for doing the show. And so, um, for me, it's been a really valuable experience just in terms of learning.
Yeah,
And so,
I feel the same way, Jay. It really has been well worth it, even if we haven't become top-rated podcast.
yep, and so and yeah, and I thought maybe next week we'll discuss all the atmospheric phenomena that or new things that we've discovered by doing our time lapse photography, and so maybe we can talk about things like air glow and gravity waves and Steves and all that sort of thing. How does that sound, Mike?
That sounds great, Jay. I love it.
Okay, so we want to thank all of our listeners for tuning into the podcast. And to continue on, you can also just check out our website. So you can keep up with Mike on at wildernessvagabonds.com. And you can keep up with my kind of astronomy stuff at skylapser.com. And we'll endeavor to maintain those sites a little bit more often and better. And you can also check out Mike's time lapses fairly regularly on YouTube. And so just look up Mike Lewinsky and time lapses, or if you just look up time lapses, he's almost sure to appear. And also mine is on my Skylapser YouTube channel. And I'm not quite as diligent as Mike, but you can catch my time lapses there as well. The intro music for this podcast is Fanfare for Space by Kevin MacLeod from the YouTube audio library. And so from the Deep Sage 9 Observatory, this is Jay Schaefer and
Mike Lewinsky.
wishing you all clear skies.